Welcome to a new video in my home automation series. And I have a new project which, well, actually it's not home automation related, but regardless, I needed a new computer that I can place at a client side. Actually, this is going to be a commercial place, and I can do some data storage and reporting on it. So basically InfluxDB and Grafana. And previously for a couple of other projects, I was using this DOSAN unit, but this had Zigbee, so this was great for a Zigbee gateway. But for this application, I don't need Zigbee, so that's one thing why I didn't consider the DOSAN unit. The second I think the most obvious one is that, and the second and the more important reason is that I got this from DigiKey and they just stopped stocking this product, and it looks like it's discontinued, but the website is still on. I was not able to get any of my contacts. They are not really responding to questions in the forum, so I'm probably not going to use this product. So hence I was looking for something else, and I came across Seed Studio and the reComputer, and couple of reasons why this is a much better fit for my particular purpose. First of all, I think it looks better. I mean, it's a more industrial look, like everything is metal here. It feels really solid. It has a DIN rail mount, so again it can go into like an electrical cabinet. But the other reason is that this contains an expansion card or an expansion slot for an NVMe drive, and because I was planning to store data, I was a little bit more concerned about storage space as in actual computing power. So I thought that to make sure that this device is going to work for a long time and it has ample space to store the data that I'm going to collect, it's better to use an NVMe than a eMMC storage, which has probably it would be up to like 32 gigabytes or maybe 64 gigabytes, but this one now has a 256 NVMe drive. So in this video I'm going to show you how this device looks like, do a bit of an unboxing, and then walk through the features. And then also I'm going to show you the new wiki page that I put together, how I install this, how I set up this machine. So basically it is, I installed the NVMe drive, I installed the operating system on it, I did the configuration, and also put Node-RED, InfluxDB and Grafana on it. And that's where I'm at the moment. I haven't really used it for anything, but if you are interested in the setup and how you can get this baby up to that spec, then obviously this video is for you. So let me start with the unboxing, and in terms of the spec, it's a Raspberry Pi CM4 module based single board computer. So what Seed Studio has done with the reComputer R1000, basically R1000 is a family, is that they have taken the CM4 compute module from Raspberry Pi, Raspberry Pi CM4 compute module, and they built a whole computer around it. So it has a lot of additional features as compared to a barebone Raspberry Pi 4B. So I don't think I would be able to show you all the things, but I'm definitely going to highlight the ones that I want to use. So this is again marketed as an edge computer, and if I just flip through the actual case, there are some stats. You can see the power supply, so it's quite a wide range of power supplies. Power over Ethernet, I think that's optional. No, power over Ethernet is built in, and then you can power it from AC or DC as well. And actually this specific model is the R1035, which has the biggest possible CM4 module. So 8 gigabytes of RAM, 32 gigabytes of eMMC. So and yeah, everything is a metal case and no fans. It's all passively cooled. This is metal, that's metal, and that's a big heatsink. And on one side you find a DIN rail mount. On the top you have still have so this is a SIM card slot, so if you want 4G, and you have 4 antenna connection. So obviously it has Wi-Fi, and you can see the Wi-Fi antenna here, which I haven't installed because it's going to be run for Ethernet. But then you have option for 2 more antennas, because then you can get additional module for Zigbee or LoRa if you need. There is a button for to get it into boot mode. On one side we have 2 network connections, so you can, if you are in a commercial industrial settings, you need to connect it to 2 different networks. One has internet access, the other one has local access. Then you have 2 Ethernet connections, one USB, which maybe if you need to flash or something, that you can use that. And actually it has 3 RS485 connections, so maybe you can use it for communication, for Modbus, that sort of stuff. You have a couple of LEDs here, that's also nice. If I go to the last side, then we have power. So it is like a universal power supply. So you have this connector that you can remove, and then you can put all the different power options here that was listed. So you can see it there as well. And then we have an HDMI display, which again, I just realized that it is such a good feature that we have, local monitor output, because the one issue I had with the Dawson unit is I have done something wrong with the Raspberry Pi setup, and I was doing some wizardry which I did not fully understand, but basically I just bricked the SSH, and that means that because that has no screen output, you can only talk to it via SSH or other network methods. So basically I was bricked, I had to reflash the unit. But here you can always hook up a monitor, you can use the USB to hook up a screen, a keyboard and a mouse, and then you can use it as a local, the screen itself, log into the, let's say the Raspbian GUI, and do whatever you need to do. So if it comes to that. But normally I wouldn't use this display, the HDMI output or the USB either. And that's it. There is nothing on the other side. And then besides all these connections, it has a lot of additional features, but I'm not going to use all the features, so I'm pretty sure I'm going to skip some of those. So one other thing I would definitely mention, that it has a built-in supercapacitor. So and there is also hardware monitoring built in, so it is possible that the Raspberry Pi can detect when the power is cut, and then there is enough juice in the supercapacitor to do a safe shutdown of the Raspberry Pi. And also it has an RTC. Again, I don't, real-time clock. I don't think I would use this, but it's nice to have. And yeah, there is some security in, cheap TPM2 chip. I don't think I'm going to use that again. Yeah, heat dissipation is a fanless design, and of course it has all the modules for expansion. So obviously wireless and Bluetooth built into the Raspberry Pi, but then you have the option for LoRa, cellular, Zigbee, and not to mention the NVMe, which was really important for me. And yeah, that's pretty much it. And you can buy a lot of additional accessories for this device. So obviously it comes with the Wi-Fi antenna that you can install, and then you can also buy a power adapter. So this is just like 12 volt 2 amps power adapter, and you can buy the SSD or the NVMe drives from Seed Studio as well if you want, which I did. And actually, I'm not going to open up the whole unit. Let me just get my screwdriver. But I'm going to remove this black back plate, so at least I can show you the NVMe drive. So that's the that's the basic installation. So I only removed the back plate in order to get access to the M.2 connection. But you can remove the whole unit because there are some more options on the other side of the board. So for example, that's where you have the Wi-Fi antenna connector, which again, you would need to do if you want to install Wi-Fi, which I opted not to do in this case. So you just remove the 4 screws, and then you can lift off this back plate. And now you can see the innards. So basically, the only thing I was interested in for this particular case is the NVMe drive connector. So, you unscrew this screw, you can put the NVMe drive, and then you can hold it down. And you have two more I think this is called a PCI Express. And that's where you can see also the tie down points. So that's where you can put like a LoRa or a Zigbee unit if you need to do that. You have the battery here for the real-time clock. There is another connector here, which I'm not really sure. Maybe, that's the same as the standard camera module from the Raspberry Pi. And that's it. And I think if I remember the documentation, you can remove these standoffs, and that's how you can lift off the entire, basically the motherboard, and access the CM4 module on the other side. And I think if I'm correct, you can also buy this module. You can also buy the reComputer with a CM5 module. But I think in my application, I'm not too concerned about the compute capabilities or, the power. I was more concerned about storage. So I think CM4 is going to be sufficient for me. Okay, so now I just connect network to the main Ethernet port. So this is ETH0, and I connect the power, and the machine is going to boot up. You see some activity LEDs here, but that's pretty much it. So I'm going to use this time until this machine boots up to say that when you get this machine, then the Raspbian is already installed on the eMMC. So you just hook it to power, network. Well, you don't really need network, but if you hook it up to the screen, then it's going to boot into Raspbian, the graphical OS, and you can access the device. So that's going to work now as well, but obviously it is going to be used headless most of the time. So I'm going to access using SSH. So for the rest of the video, I'm going to show you this page on my wiki, which I'm going to link in the video description below, how you can access this page where I've done all the documentation, what you need to do in order to set up this computer. And you can see that it is working now, and I'm logged into the reComputer using SSH. So going through this document, so I'm just going to show you, basically just going to talk through this document. I haven't created the whole screenshot. I haven't recorded all the actual setup. It took me a couple of hours, and I also ran into some rabbit holes which needed me to pause for a week until I get some support from Seed Studio over the forum. Before I go ahead, I just wanted to say that, I already mentioned there is a Raspbian installed already on the eMMC when you get the machine. And so it doesn't use the usual Pi and Raspberry, but it uses reComputer, and the password is 123456778. So if you want to use the standard installation, that's how you can log into the computer using SSH. And you would definitely need this information, because the first thing that we are going to use is we are going to set up the NVMe drive, so the SSD, because we want to boot from that drive. So technically, the built-in eMMC storage is irrelevant in my case, because I'm not going to use it. So that would be basically just a secondary drive, and the reComputer is going to boot from NVMe, and it's going to use NVMe as the main storage. So in order to set up, obviously you need to boot into you need to set up start configuring the system without the NVMe installed in it. And there is a very good document in the Seed Studio wiki what you need to do. So there are a couple of commands that you need to execute, and basically you just need to copy and paste all these commands here. I mean, obviously, read the article, have to save this file, press this button, and save, and then make sure that you have this message at the end. So it's very straightforward. It only takes a couple of minutes. And then once you have done that, you also do this. You also perform this second section here, which is flash the latest EEPROM and modify the boot order. So again, you just need to go through a couple of steps here. Just follow the instructions and everything, and then that should take you to the end of the the settings. And then when you reboot the machine, it's going to boot as normal, because it would try to boot from the NVMe, but if it's blank or if you haven't installed it, then it's just going to fall back to the eMMC storage. So that's what the NVMe setup is. And the next step is that you actually have to install the Raspbian OS on the on the SSD. And actually there is a documentation how you to do that. And I tried following the documentation, but it just didn't work. So I couldn't get my laptop to recognize the SSD on the reComputer, and I got stuck. And actually this is where my life on this whole setup stopped, because I wasn't sure what to do. So actually I turned to the forum and they said, well, the best option is that you format the SSD outside the reComputer. So what I ended up doing is actually I bought this USB-C or USB external enclosure, and so this is just an NVMe drive enclosure, and then you put the NVMe here, you connect it to USB, and it appears as a mass storage device. And I think you can just buy any enclosures. Mine is a off-brand Alza Power. If you are from the US or from Western Europe, Alza is like a, Central European Amazon. So they have this branded card, it's metal, it looks nice, and it was, I don't know, 15 bucks or something like that, or even less. So it's cheap stuff. And then, Seed Studio even recommended, and others recommended that you do this because that's the easiest way to do. So you set up the NVMe, you put it into this drive, you connect it to the computer, and then you have to download the Raspberry Imager and you have to launch it. So once you've done that, that's how the Raspberry Imager looks like. So you choose the device, which is Raspberry Pi 4, and the OS system is Raspbian. Well, this is what I choose. And then when you choose the storage, then the NVMe or the SSD should appear in this pop-up. And then you click that, and then probably another important thing, which I always forget, that if you press Ctrl-Shift-X, then you have a pop-up screen. And then that's going to, it will allow you to make some general settings. So you can change the host name from reComputer to something else. You can here specify the admin user ID and password here. You can also set up a wireless SSD if you want, straight here. You can change the locale. In the services, you can enable SSH to use with password authentication. And that's it. So once you have done this and you selected the image, you click next, and then probably there is another next or something, and then you can install, and that's going to flash the OS onto the SSD. And actually, if you want to read a little bit more about this, there is a separate article on this which has screenshots of how you select. It looks like this screenshot is a little bit outdated, and it even shows you how you do it in a Mac, but I'm doing it on Windows and blah, blah, so you can scroll through. But I think it's a very straightforward process. And then you use the documentation. You can look up a YouTube video or go to the Seed Computer how you install the NVMe drive. But I just showed you how to remove the 4 screws. You remove the backplate, you put the drive in, and then you close everything up. And then once you turn on the computer, it's actually going to boot from the NVMe drive. And you can check that if you execute df/boot, then you will see that it says that the file system is /dev/NVMe something. So that shows that the boot device is not the eMMC storage, but the NVMe drive. Okay, and now we have done that, we have some other setup that we need to do on the system, which is setting up the reComputer specific drives. So just before there is an article for that. So install the reComputer R1000 drivers and flashing the new Raspbian OS. So here we can skip this part for the 32-bit because the CM4 is a 64-bit, and then we can just do the step one. So you clone this repo, and then you enter the repo, and then you execute this, and then you reboot the machine. That's it. And it says that if you have the version 1 of the reComputer, so basically if you buy your device now, you're most probably going to get the version 2, and the version 1.0 had 2 antenna connectors here, or placeholders, but a version 1.1 has 3, just like mine. So if you have free, then, well, obviously this section doesn't apply to you, so you don't need to do any of this. And that's the, the setup for the reComputer specific drivers. So after this, we basically at the same point where we were with the, the factory installed operating system, but now it's on the NVMe drive. So now we can start installing our, specific applications. So first of all, I installed Node-RED, which again was very easy because all I needed to use is to use the update script. Oops, I put the wrong link. I meant to link this one. So this is the upgrade script that you have to execute. So you just copy this, paste it in, and that's the usual update script for Node-RED. And because there is no Node-RED installation, it just basically going to do a fresh install of Node-RED, and it's going to install all the latest Node.js libraries and npm and whatever is required for Node-RED. And it's literally just waiting for all these steps to complete. There are a couple of questions at the end. It asked me if I want to install the Raspberry Pi specific nodes. Even though this is Raspberry Pi based, I choose not to do this because I will not be using those functions. But you can do it, or you can do it later. It doesn't really matter. And yeah, I mean, it would install it as a service and everything, so everything is going to be fine. And what I noticed that this script, I think this is probably also a later addition, is this script also runs the Node-RED init, which is, I think it was added at 3.0 or 4.0, where it takes you through a couple of questions setting up a new Node-RED instance. So it's going to ask you a bunch of questions like, what's going to be the name of your flow file, like your basic directory, and the most important thing is that you need a passphrase for the flow file. So obviously I set the passphrase. That's something that you note down just to make sure that you have it, and that was it. So after that, you can just start Node-RED as you would start normally. So I think the script also creates the systemctl and enables it. You can make some changes. So if you go to, I mean, I like to set up a static folder, so I do that configuration. I also like to modify the context storage, so I can get either context storage in the memory or in the file. So I made those two changes to the config.settings.js file, and which actually is here in this documentation. It's already mentioned in the documentation that I used for my old Node-RED server, and things haven't really changed, so that these settings are still valid. So after that, you have Node-RED installed, and now we can move over to InfluxDB. And I was, looking at InfluxDB. I wanted to go through the documentation, and I noticed that there is a new version of InfluxDB, InfluxDB 3, and this has the same sort of like core or OSS, so self-managed installation option. But the one thing which Influx 3 is missing is that they no longer support the Flux query language. So you can read about here in the forum as well, but basically the Flux query language is no longer supported from InfluxDB 3.0 onwards. So the option is simple SQL or the InfluxQL language. And just because I spent so much time understanding how the Flux query language works, and I quite like to use it and how you can, massage data and transform it, I decided for this particular project, I'm going to install the, the 2.x version or 2.5 version of InfluxDB, which still supports Flux, and I'm going to tackle, learning InfluxDB 3 and the InfluxQL language probably as a different project. So for that reason, I actually decided that I'm going to use the same, well, as I said here, I'm going to use the older version of the InfluxDB. By the way, the Flux query language is made obsolete or no longer supported, but that means that they are still going to support it for, you know, patches and fixes, but they are just not going to you know, put more effort into adding new functionalities and enhancing it. So you can still use it. There is no, you know, sort of like deadline for the language, so probably it's going to live on for a good few years. I don't know, 5, 10, I'm not really sure, but I think it's going to be good enough for this particular project. And because I used, well, I'm using the same InfluxDB version that I used for my own Node-RED server, the documentation that I had previously is actually still valid. So there is an installation for InfluxDB OS version 2. So here you select that you want a Linux installation, and I decided to install InfluxDB as a systemd service, and actually installation is like that much, so it doesn't take a lot of stuff. So you know, download some keys, and then you add these keys, and then finally you get you do an update and you install InfluxDB 2. And when I did that, I got some error messages, and if I read this post, I think it says here that I was getting these type of error messages, some GPG error, and some repository is in release is not signed. So apparently this is some keys that are not correctly maintained, and here I found these few steps that I linked in the documentation that I executed. So I had to remove some of these keys, and I had to execute these to put some new keys in, whatever that means. I don't try to pretend that I understand what's really going here. So you execute these commands, and then you execute these commands, and after that you can install it. So for the second time I did the sudo update and the sudo apt-get install InfluxDB 2, and then it installed without any issues. And also what I mentioned here is that in my previous documentation that I did for my other server, I had to install InfluxDB and the CLI, which is the user interface, as a separate installation, but it looks like it's bundled into one single package now. So after I've done that, the InfluxDB was running. So if I take this, and obviously I replace it with the URL of my, I think it's 171 now, then I'm in InfluxDB. So when you put in this URL, obviously you don't get this login screen, but you get a get started screen. So you just have to go through the process. It's, you know, fairly self-explanatory. It will ask you to provide your user, so admin user and password, and it's also going to give you an admin token, which you have to write down, save it somewhere, because you're not going to see that token anymore. And yeah, after that I just signed in, and as I said, I haven't really created anything yet. So you can see that I just created a test bucket. So I have data, I have something, and I also created the some sample data. I think I used, did I use actually ChatGPT to generate some sample data, which generated some sample data for me in 2023, but at least I was able to test that I can ingest data, and also I can test some of the, you know, the query functions, just make sure that, you know, things are working. Yeah, so you can see that temperature, greenhouse, if I execute, I get one single record in 2023. So again, that was just enough for me to get started and just make sure that the database engine is working and everything is working. And that pretty much concluded the InfluxDB setup. Actually, it was easy. And then next I did the Grafana installation, and here again my earlier document was sufficient enough to install Grafana, which again just links to the actual Grafana installation on Grafana's page. And yeah, you just have to go through, I mean, Raspberry Pi OS is Debian based, so you just go through these steps here. Yeah, so you do 1, 2, 3, 4, 5, 6, and obviously you, you don't do step 3. You don't do step 4 because that's the beta release, And then you don't do step 7 because we want the OSS version and not the enterprise version. So the OSS is the self-managed version of of Grafana. I think I have to mention it here that you obviously don't do this, the two things, step 3 and 7. And once you do the installation, then you can start Grafana at the port 3000. So 1.171. And when you have, okay, I'm already logged into Grafana, but the default password and the default login for Grafana, I think I have it documented here. Yeah, it's admin / so the user ID is admin, the password is admin. And obviously once you get in, then you change your admin password to whatever you want. And so that was the Grafana installation. So the only thing I needed to do in Grafana is to set up a database connection to InfluxDB. So where is it? Under data sources. And then you create a new data source and then you search for InfluxDB. So, and then once you have it in InfluxDB and you give it a name, again, because I wanted to use the Flux query language, I selected that, specified that the query language is Flux. And then what is the URL? So the Grafana and InfluxDB is running on the same server. So it's 127.0.0.1 and colon 8086. So the, that's basically localhost and the port 8086. And I hasn't changed anything here. So there is no cookies, no header authorizations, no headers. So you have to provide an InfluxDB database details. So first of all, organization. Again, that's something that you specified when you set up your InfluxDB, when you did the initial setup. And you specify the test bucket, and you also put the token here. So the token is, I think in my previous documentation, I said that I want the, you provide your admin token here, but I think it's probably a best idea if you create a new token just for Grafana, because then you can say a custom API access. So you can put a name here like Grafana. And I specify this, that it has read access to all the buckets. I mean, you can restrict it to whatever bucket that you want, but at least the Grafana plugin or this database connection will not be able to accidentally write to any of these tables. So that's how I set up the new API. And when you generate, you get the API key, and then you put this API key here, and then you do test and save, and it says, oh yeah, it is working, and it's found one bucket. So that's the test bucket. I mean, you can delete the default bucket, so it's going to see all the buckets. Or, once you change the bucket, your main data bucket, then you can change here as well. But that's pretty much it. And I think I even created a dashboard just to test. So you can see again that the window is set to 2023 because that's where I had the data, and I created a very just simple panel which has this very simple Flux query, which does the same thing what I did in the Database Explorer. So it basically just selects that environment greenhouse temperature. That was the same sample data that I got from, I think it was ChatGPT. It was ChatGPT. Can you create an environment data in InfluxDB line protocol format? And then it came up with this data. I could have maybe deleted these timestamps, so it creates it with the current time code. But yeah, that's fine. It's in 2023. And then you can do like, what is it? I think it's on the, no, it's here, sources, and then line protocol. And then you can just, you can line protocol, you can paste it. Oh yeah, enter manually. So you can just paste that stuff in. So copy code, paste this in, write data. And that's how I got my very simple sample data. Again, which was just good enough for test the database connection and the Grafana, and then make sure that everything is working before I start ingesting data. And that's pretty much it. So this is where I am at the moment with this machine. It has everything installed on it, so it can be, it can go to the final basically site, and once it's there, I can do the reason I'm using Node-RED, because it's going to collect data from Modbus. So I'm going to use Node-RED to read the data from Modbus, although I think I should be able to do this with Telegraph, but I probably would need to do some additional logic in Node-RED anyway, so why not just collect the data with Node-RED? I think I have more control about, what registers I want to read, how I want to store them in maybe different metrics, or is it called metrics? It was such a long time ago that I used different measurements and different keys that I would need to use. So yeah, most of the sort of the interfacing is going to be done in Node-RED. It puts the data into InfluxDB, and I can start building, various dashboards in Grafana. So that's going to be the end goal, but the setup is complete. The documentation is going to be available in the video description. And I think that's all going to be for today. Thanks for watching, and hopefully see you in the next one.